Okay, section 8.6. This is not a right triangle. It seems like this whole entire chapter we've been talking about right triangles, haven't we? Well, here's a triangle that's not a right triangle. Do you remember what the guy on the video yesterday called it? What did he call it? Oblique, right. He called it an oblique triangle. I don't really care if you call it that or not. We just know that it's not a right triangle. With me? Now, we learned some ways. Now, when we did have a right triangle, we learned some ways to solve for missing sides and angles of a right triangle. And that was using our trig functions. What were our basic three trig functions? Yep, sine, cosine, and tangent, okay? We cannot use sine, cosine, and tangent on a triangle like this. Why not? It's not a right triangle. That's right. I want to get that through your head, all right? Because a lot of people tend to do that. In my honors class, when we did this chapter, even on the test, we had non-right triangles, and guess what some of the people were trying to do? They were trying to use the sine, the cosine, and the tangent on a non-right triangle. Okay, you can't do it. You can only use that stuff when you have a right triangle. So this is a way that you can solve for missing sides and missing angles if you have a non-right triangle. You got it? Okay, so let's label this thing. Let's call this angle A, call this one angle B, and call this one angle C. Now again, the guy on the video yesterday that I showed talked about this, but we're going to review it a little bit. If this is angle A, what am I going to call this side right here? I could call it side BC, couldn't I? But let's make it a little easier and call it what? Side A, little a, right? This would be lowercase. This is capital is the angle, the lowercase is the side. How do I know this is A and not this one right here? Or this one? Because it's opposite, that's right, because it's opposite angle A. Everybody got it? This is very important for when we set up the formula for what we're going to do today. And you know what we're going to do because you kind of looked ahead yesterday when I showed that video. Okay, so here we go. What would this side AC be called? Instead of AC, we could call it what? Side B, and then AB would be what? Side C. All right, everybody got it? Because it's opposite angle C, B is opposite angle B, and little a is opposite angle A. You with me? All right, we had a little formula. They called it a little law. And you remember what that's called? The law of sines, right? The law of sines. You could write it two different ways, and I'm going to show you a little hint. He didn't really allude to this yesterday. I'm going to show you a little hint that makes the math just a little bit easier. So there's two ways to write this. You could write, now it's a law of sines, so what do you think is going to be in there? It's going to be a sine, right? So do you remember how he wrote it the first way? Sine of A over what? Over A, side A, right? Equals sine of angle B over side B, right? And then sine of C over C. Right? So watch this. We're not going to use all three at the same time, are we? We're only going to pair them up. We're either going to use the A and the B together, either the B or the C, or the A and the C. So we're not really using all three of them. We're just kind of pairing them up like this. Does that make sense? So I tell you what, I did this in the last class. I think we're okay with doing this. Let's just kind of forget about the C right now, and let's just pair them up like this. Now, how many different parts of the triangle are on here? Well, there's an angle A, there's a side A, there's an angle B, and there's a side B. There's four of them, aren't there? Okay. If I know three of these four parts of the triangle, I should be able to find the fourth part. You follow me? Okay, you guys are paying attention, right? Not worried about passing notes and all that kind of stuff? Okay. All right. It would be really nice if you watched and paid attention. I'm trying real hard here, and it doesn't seem like there are some people in here that are paying much attention. So here we go. I've got four things. If I know three of those four things, I should be able to find that fourth. Okay? And you could cross multiply and that kind of thing. Now watch what I'm going to do. I wrote it like this. There's two ways to write it. If I wrote it like this, if I was trying to find the angle, like angle A for instance, I would put the angle on the top. You follow me? So let's say I didn't know angle A and I was trying to find it. Then I would put the sine of A on the top. I wouldn't put it on the bottom. I'll show you another way to write it. Now, if I was solving for, let's say, side A, how do you think I would write that? Put A where? On the top. So whatever you're solving for, I would put that one on the top. Right? So if I put it on the top, here's another way to write it. And he showed you this in the video yesterday. Another way to write this would be what? A over what? Sine of A. So this is really the same exact thing. But that would equal what? B over the sine of B. All right, side B over the sine of angle B. Got it? So you could write it either way. I think what I would do, I would pick whatever you're trying to solve for and put that one on top. I think that would be a little bit easier, don't you? So if I'm solving for an angle, I'll go sine A over A. If I'm solving for the side, little a, I would put A over the sine of A. You with me on that? And you'll see that how that works here in a second. All right, let's copy that, and let's do an example. Actually, I'm going to draw the triangle a little bit differently because this one in the book draws it a little bit different. So draw this. This is an example. Something like that. I'll tell you what, let's angle that a little bit more. It doesn't really matter. No, sorry. I should have just kept it the way it was. It looks like a right angle, and I really don't want it to look like a right angle because it's not. Let's try this again. That looks a little bigger than a right angle, doesn't it? Okay. Alright, so here we go. Let's put some numbers in here. And we're going to do our first law of sines. So this angle right here is 97 degrees. This one down here on the bottom is 21 degrees. This is 16. And this is x. So that's what we're trying to solve for. We're trying to solve for x. Alright, well, let's see what we have. By the way, I talked about this a little bit. Remember I said 3 of the 4 things? But there's one thing that you really need to know. You have to have, listen, to use the law of sines, because there are situations where you can't use the law of sines. The law of sines doesn't solve for every single triangle with missing things, okay? Only certain situations can you use the law of sines. And here's one. Look at this right here. You have to know, remember, 3 of the 4 things? So you have to know an angle, at least one angle in the side opposite that angle. So when I look at the triangle, I have to have, if they tell me an angle, I've got to know one of the sides across from that angle, okay? Now look at this. Let's say I was trying to solve for B. So I can have that missing, but the side opposite the angle I'm trying to find has to be right here. Does that make any sense? You'll see when I do the example. I don't know if I explained that very well, but look at this. Do I know an angle and a side opposite the angle? Do I actually, yeah, the 97 degrees and the 16. So far so good, right? Now look at this side that I'm trying to find. I also need to know the angle opposite this side. Do I know that? Yeah, I do. Okay, so yes, I do know that. So I'm good. I'm good with using the law of sines. You with me on that? Okay, so let's set it up. I'm trying to solve for a side, aren't I? So what am I going to put on top? Am I going to go sine of angle A on the top? No, I'm going to put, right, A over sine of A. And now in this case it's not A. It's what?
Over 97.
Yeah, we could do that. Let's do the variable first, though. You're right, we could do that. X over, right, the sine of 21. Everybody see what I just did right there? If I'm trying to solve for x, look, I look at the angle that's opposite, and so I go x over the sine of the angle that's opposite that x. See it? So I'm using those two. I'm putting those two together. So I just decided, hey, I mean, I could have written it sine of 21 over x, couldn't I? That would have been okay. But I think it's a lot easier if I put the x on the top, if that's what I'm trying to solve for. Equals. Now, what's the other 2 things that we know? Yeah, we're going to use the 16 and the 97. So the 16 goes on top, right? Because we're putting the side on top this time, over the sine of 97 degrees. You with me? All right, so that's pretty easy, isn't it? Setting it up like this. Let's change colors here. Now, what am I trying to solve for? X. What do I have to get rid of if I'm trying to solve for x? Sine of 21. How do I get rid of that sine of 21? Yeah. Just multiply. Just multiply by the sine of 21. Because what's happening? This is being divided, isn't it? I'm not doing the inverse function. I'm not doing that sine to the negative first thing. All right? Because this is already the sine of 21. I'm not trying to get anything by itself there. I'm just trying to get rid of the sine of 21. The sine of 21 is just a number I can stick in my calculator. So what if this was like x divided by 3? How would I get rid of that 3? Multiply by 3. Well, it's x divided by this crazy number right here. So I just get rid of that by multiplying by the sine of 21. So that'll cancel, right? And then I got to multiply this by the sine of 21. Make sense? Well, it's 16. It's over 1, right? Sine of 21 over 1. So I don't multiply the bottom by it because this is sine of 21 over 1. All right, so yeah, technically I only multiply the top by it. Got it? All right, so that canceled out. Look what I have. I get x is equal to, let's write this a little bit neater. 16 sine of 21 degrees over what? The sine of 97. Now, at this point, what are we going to do? Plug it into what? Calculator. Just happen to have a calculator here. All right, so there's our calculator. This is what we're going to do. Now, let me show you how to do it on this calculator. Then we'll talk a little bit about how to do it on the other one, that TI-30XA that a lot of you guys have. So on this calculator, I go 16. Is anybody actually using a graphing calculator? Who has one? One. Who else? Just one person in here? Two? Okay, just two of you are using a graphing calculator? Okay, that's fine. I mean, you don't have to have one in here. So anyway, it's 16 sine of 21, all right, divided by what? Sine of 97. Sine of 97. And then hit enter, and there it is, 5.77. Let's round it to 5 point what? 8. So 5.8. Why did I put little squiggly things there? It's approximately, right, it's approximately. It's not exactly 5.8. It's pretty close, though, all right? 5.77, blah, blah, blah. So it's about 5.8. And that's what this value is right there, 5.8. It's not hard at all, is it? Okay? So just because we don't have a right triangle doesn't mean it's all that difficult, but we use the law of sines to do this. Make sense? Now, how would you do this on your 30, on your TI-30?
You do sine of 21.
Well, not sine first. What would you go in order?
You do
21.
I like to do this. I like to figure out what this is and then multiply by 16. Right. So hit 21 sine.
and then hit 97 sine.
Well, let's stay with this. 21 sine, what? Times 16. Okay. Now, I don't think you have to hit equals, but I always do. I would hit equals. And then I would do what? Divided by 97 sine. All right, but then you got to hit equals again. No, not by 97. Divide by 97 sine, then equals. So here's the number. Watch, this is how we do this. I'm going to hit 21. Watch, these are the numbers you punch in. 21, then you hit sine. Do this in order. Don't go ahead. Do this in order. You guys got your calculators trying this? You got to practice this stuff. If you don't practice this stuff, you're not going to be able to do it on a quiz or a test, I promise you, because you got to be used to doing this. You hit 21 sine, you'll get some decimal, right? Then you hit times, and then you hit 16. Okay, and then you hit equal. I like to hit equals. Is it 5.7? Okay, and then, so you hit equals, and then what do you hit? Divided by, right? So hit divided by, and then, skip down here, hit 97, and then hit sine, but that's not your answer. Because right now your calculator is just telling you what the sine of 97 is. What do you have to do to get this division? You hit equals, and then you should get 5.77. Whoever's making that noise needs to stop. You should get 5.8 or 5.77, blah, 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 right? So try it. You got to practice it. I'm telling you. Gone are the days when it's just 3 plus 4. You stick it in a calculator, you get an answer, you don't have to think about it. Now you have to think about what you're putting into the calculator. You got to be careful because there's a lot of different steps here. Practice it. Sounds weird for a teacher to tell you to practice using your calculator, especially after all the times I've yelled and screamed about not using your calculator, right? But in this situation, you absolutely need your calculator. Okay, I told you I didn't hate calculators. I just don't like you using them when you don't need to. This is definitely a situation where you need to use them, okay? You definitely need to use it in this situation. They used to make charts, and I don't even think they have a chart in this book, but they used to make charts. They put them in the back of the book, and they would have like a sine. Well, they have some angles, right? They'd have angles, and they'd have sine, cosine, and then they would have tangent. And they would list the angles, 0 degrees, 1 degree, 2, 3, all the way to like 90 degrees, all right? Then they would tell you what the sine of each of those was. Right, and then it was like point whatever. I don't know what they are, but they would give you decimals. They would give you decimals for those charts. You could probably go online and find those charts if you wanted to. But yeah, that's the way we used to do it before the calculators. Right? Talk to Mr. Jackson sometime. He uses a slide rule. You ever hear of that? You've probably never even seen one before. My dad was a teacher for a long time, and before the calculators, he'd always carry a briefcase, and in that briefcase was a slide rule. Well, it's not an abacus, no, it's not an abacus, but it's a slide rule. It's actually kind of cool. It's got a whole bunch of numbers on it. It's just a little piece of wood about this big, probably about, I don't know, 6 to 8 inches big, and then just real thin, and it has a couple levers on there. Not levers, but little slide thingies on there. Some are clear. It's got these lines. I don't even know how to use it. I've never really used one. My dad showed me like one time how to use it. But I don't really need it. You don't really need it because you've got a calculator. I bet you anything, Mr. Jackson either has it in his classroom or he's got one at home if you have him for science. Anybody have Mr. Jackson for science? No, he's not at home. All right, so let's do another one. Let's see. All right, here we go. Now, in that one we found, listen, we found a side, didn't we? So what do you think we might be solving for this time? An angle, that's right. Okay, we're going to solve for an angle. So here's my triangle. Let's see what they tell you. They say, let's do this in a different color. Let's say this is x degrees right here. All right, that's what you're trying to solve for. Now you're trying to find an angle. So, yeah, so you will. You're exactly right. You will do the inverse to be able to solve for the angle. There we go. All right, first of all, let's look at it and see if we can use the law of sines on this. So here's what we're trying to solve for, right? So do we know the side that's opposite this unknown angle? Yeah, we do. So far, so good, right? But now we have to know another angle and a side opposite that angle. Do we know that? Yeah, here's an angle, and we know the side opposite that angle. They're not always going to give you that stuff because there's another law that we're not going to talk about today. We'll talk about on Monday probably, is the law of cosines. So there are situations where you can't, use the law of sines. In this situation, it's perfect to use the law of sines. All right? And I'm going to give you a worksheet today because this lesson really covers law of sines and cosines in one lesson. I'm splitting it into 2 days. All right? So I'm just doing law of sines today. So half the problems on today's worksheet use the law of sines. The other half use the law of cosines. All right? So we're only going to do about half the worksheet tonight. All right? So here we go. What are we trying to solve for? An angle. Do you remember how we set this thing up? Yeah, put the sine on the top this time. So it's not a, but it's what? It's x, right? So we put sine x on top over what? Can I pick any of these numbers? 10. Why 10? Because it's opposite the angle. Very good. All right, equals. Now, we take the sine of the one angle that we do know. What angle do we know? 45. Now look, just because that's a 45-degree angle, does that mean this is a 45, 45, 90? No, it's not, because I only know one angle. I don't know if the other one's 45, and I don't know if one of those is 90, do I? So I don't make any assumptions about it just because that's 45. So it's sine of 45 over what? 8. There we go. We've set it up. That's the hardest part. The easy part is doing the solving, I think. And look what we're trying to do. We're trying to get x by itself, aren't we? We're trying to get that one by itself. Let's go to a lighter color so I can see it. That's what we're trying to solve for. So first things first. What are we going to get rid of? Just like we did the first time. Not the x. The 10. That's right, because this is being divided by 10. So get rid of the 10 first. So how do I get rid of a 10 if it's being divided by? I multiply it by the 10. Okay, keep the sign of x right where it is. Just get rid of the 10. So we multiply this by 10. Now watch very carefully. I don't put times 10 right here. That's not how I want to write it. I want to write it a little bit nicer. I'm going to put that 10 right in front of that sign. It means the same exact thing. Everybody see that? So it's 10 times the sine of 45. That's a better way to write it when we're using signs. 10s cancel out. So what are we left with now? Sine of x equals all this. So let's write it out. 10 times the sine of 45 over 8. Now we're not quite done. We're almost there. We have to solve for x though, don't we? So there's a sign in front of it. Now, how do I get rid of that sign? We've done this before. You're right. Exactly right. We take the inverse of the sign. Taking the inverse of this, we'll get rid of it. So I'm going to be left with just x. But if I take the inverse of sine on this side, I also have to take the inverse sine of the other side. How do I show that? What's the way that I write it? Sine to the negative first. That's right. That's how we write the inverse sine. It's not the first time you've seen this. We've seen this a couple times now, haven't we? More than a couple times. So it's the inverse sine of this thing right here. So let's just rewrite this again. So it's all together, nice and compact. And now, that's supposed to be a 5. That's kind of ugly. Now it's ready to put into your calculator. Right? Now it's not that big of a deal. Let's slide this over right here. So let's put this stuff in. Let's see about this. I'll tell you what. Let's do this stuff. Let's put all this stuff in the calculator first, and then at the very end, after I put this on there, then we'll take this inverse sine. Now you could do this in order. You could go inverse sine first if you wanted to, but I'm just going to do it like this. So watch, let's go 10 sine of 45 divided by 8, and then I'm going to get an answer for that. That's your decimal. That's not my answer though, is it? What do I have to do to that stuff? Well, not divide it. Use the word again. Take the inverse of it, which in this case is the second function, right? So, second function sine, everybody see that? Looks just like this, doesn't it? Of all this stuff, do you remember how I do this on this calculator? I hit answer. I don't have to type in 0.88388346765. I can just do this. I can hit second function. See where it says A and S right there for answer? Boom. Right there. And so what it's doing is taking the inverse sine of this whole thing, and there it is, 62.1. So x is equal to, well, it's approximately equal to 62.1. 62.1 what? Is that a length of a side? It was an angle, right? So, right, we put degrees on there, don't we? So it's 62.1 degrees. Now, if you were to do this on the 30XA, all right, the TI 30XA, how would you do that? It's really not that much different. Watch this. You watching? You should be practicing. You should have your calculator out in front of you, and you should be practicing that. A lot of people don't, and you're not punching anything in. Let's try it. What I would do is this. If I had a TI 30XA, I would hit 45 first, and then what? Then the sine. Okay? Then times 10. Very good. Okay? So that's the top. Personally, I like to hit the equal sign now. All right? Then I hit this, which is what? Divide, and then 8, and then hit equals. That's not my answer, though, is it? It's just that. You should have that 0.88 number, right? Then all you got to do is hit second function sine, and boom, there's your answer. You don't even have to hit equals. Hit second function sine, and you'll get that 62.1. Am I right? Yeah. Practice it, okay? Don't just do it once. Don't just sit there and listen to me tell you how to do it. You need to practice it. Use your calculator. Practice using your calculator. And that's basically it right there. All right? And, yep, law of cosines is next. So that's it. I'm going to give you a worksheet. And it's section, what is it, 8.6 I said? Oops, section 8.6. No, I didn't give you homework last night. All right, so watch. We're only going to do half of these problems. Let me see what problems. Let's see. You're only going to do 1 through 8. All these are the law of sines. Every one of these problems are the law of sines. After this, you're going to do the law of cosines. So if you want to, you could try to do number 9 with the law of sines, but you're going to get stuck because it won't work.
So don't even try.
Well, actually, I don't know. I'd have to try it. It may work, but we'll just do 1 through 8, okay? Just do 1 through 8. Everybody good? All right, that's it. Have a good weekend.